Hi, everyone. Thank you for joining our show, podcast Tech Talk, where we talk about various technology-related topics. Today is a special episode because we have a very special guest with us today, Eben. He is the co-founder of Raspberry Pi, and anyone who is related to technology in any way would know about Raspberry Pi. Is a revolutionary product. I have one, Amit has one, and we both use it for various purposes. Eben, very pleased that you could join us today in our show. We are just gonna pick your brains on various aspects of Raspberry Pi. We're very interested to know how it all started and the overall journey that you've gone through, and potentially the future plans that you have to make it into even more awesome than it already is. So I'm just gonna start with just give us a little bit of background about Raspberry Pi. When did Raspberry Pi started? What was your role in founding it?
Um, s- well, Raspberry Pi is about, as an idea, is about 15 years old. It comes out of really kind of, I guess, two strands of work. One's building cheap computers. I've always liked building. I've always liked building. I'm a software engineer, but when I started doing hardware stuff, the thing I was interested in was building affordable computer hardware. So I've been building. I built the first thing you could call a Raspberry Pi back in about 2006. I was built on a microcontroller platform, and it was a kind of a cute little toy you could build in an afternoon out of the same sort of microcontrollers that you use in an Arduino, for example. Um, so I did that back in 2006. And then that kind of strand of work, I guess, collided with um, this concern that we had that there aren't enough young people who are interested in computers anymore. There aren't enough young people who are interested in learning to program. And really, these two things came together in about 2008 as our numbers of I'm based in Cambridge in the UK, and the number of people applying to study computer science was declining year on year. And we were very concerned that we wouldn't have enough. Eventually, we'd get to a point where we didn't have enough students to maintain the viability of computer science as a subject at Cambridge.
Wow.
And so there was that concern, and so then there was this interest in building hardware. And so what I was asking myself was, well, if I could build a piece of affordable hardware, get it into the hands of children, maybe they'd become more interested in computing, and then they would apply to study computer science. And that's really where the idea of, so by 2008, I and a group of my colleagues at the university, we were thinking about we'd really started to think about Raspberry Pi in fairly recognizably modern terms as not that would create computer hardware to get young people excited about computers.
Okay,
All right.
I mean, the name, I think Raspberry Pi, everyone is, I mean, always, it's a pi. Is it a pi? Is it the mathematical symbol? Why raspberry? Why not blueberry? So why the name?
So it's a two-part name, and there's these wonderful. I think early on there were some people in Cambridge, there's fairly influential people in the Cambridge tech community who thought we'd had a great idea and we'd spoiled it by giving it a stupid name. But the stupid name is a two-part stupid name. Raspberry is fruit-named computer companies. There's a lot of fruit-named computer companies. So we in the UK had apricot and tangerine and acorn, of course, which is technically a fruit. I think there's another big fruit named computer company out there somewhere as well.
Apple.
And yeah, oh, might be one of them. Yeah. And so yeah, I mean, there aren't actually that many fruits left. Blueberry actually was the other one that we thought about. Raspberry is funny because, of course, raspberry blowing a raspberry is like that, and that was a thing. Because so there's a thing with kids where so Roald Dahl, the children's author, had this idea that the funny one of the funniest funny thing that happens for children is if an adult farts. And the funniest thing that could ever happen would be if the Queen were to fart. And so we sort of thought it would be funny to have Raspberry as the name of our computer company. And then Pi is Python. We're big believers in Python as a programming language. I grew up with BBC Basic, which is, kind of a lot of people of my generation are Basic kids. And really Python kind of takes that sort of approachability that Basic has, but adds a layer of rigor, adds a layer of structure to the top of it. Kind of raises the ceiling. The thing with Basic is there's always going to be a point you get to with Basic where you can't really you need to stop and use a real programming language. Where with Python, Python really is a real programming language, but it's still a programming language where the hello world programming in Python is print hello world, just like it is in BASIC. So you can kind of go to a kid and say, hey, start programming in this language, but all like the big engineers, real engineers at Google, they all use this language as well. There is no top rung to this ladder. So Pi is Python. It's PI, not PY, because we thought the Pi logo, the Pi letter would make a great logo. And we didn't use that in the end. We have a picture of a Raspberry, but we thought it would. So that's where our name came from. And it's a stupid name, but it's a great name, I think.
It is a memorable name.
It's memorable. It's and nothing else is called Raspberry Pi. It's very easy to nothing else is called Raspberry.
Great. No, that is really interesting. No. Sorry, Amit, carry on.
No, so I mean, I was reading about the history behind BBC Micro, and I was reading some other tech news related to your founding the company, and the project itself. And you mentioned that MIT was about to launch a project, something similar, and that actually prompted you to do something and launch a British project.
Yeah, and then nothing happened. The MIT thing was not a real thing. It turned out. I think they were going to make an Apple II or something.
Okay.
Some idea to make an Apple II, and obviously with the BBC Micro in the UK, the idea was, well, we should do a BBC Micro. But I mean, the devices, even the very earliest devices, were much more powerful than a BBC Micro. That MIT thing, I remember that. I mean, it was extremely valuable, right? Because it got us off our seats, got us off our backsides, and made us try and build something. But by the time we got anywhere near having a real product, the MIT thing wasn't the thing anymore.
Okay.
Right. Okay. So I'm really curious to know, because obviously I've used Raspberry Pi to mine cryptocurrency, but when I go on YouTube, I see many people doing many projects. But it must be that you get to see a lot of cool projects. What are some of the coolest projects that people have done with using Raspberry Pi?
Projects with Raspberry Pi. I love the robotics ones. There's a whole world of robotics.
Yes.
Raspberry Pi. There's a thing called Pi Wars, which is run by Tim Richardson and Mike Horn in Cambridge in the UK, where people come from all over the world and they make to race against each other and fight with each other, like a little robot wars kind of thing. So I love the robotic stuff on the hobbyist side. On the sort of more kind of business oriented side, you get a lot of people using Raspberry Pis as alternate PCs. I guess particularly Raspberry Pi 4, which really has kind of a PC-like level of performance. You see a lot of that. And that's super exciting, and it's been super exciting during the pandemic, when obviously people have needed, have often needed to get computers at low cost and short notice. And of course, we've had hardware to do that with. So that's been a good experience. Over half of Raspberry Pis now are sold into industrial and commercial applications. So you see people automating factories with them. You see people building products around them. So you see.
Oh, right.
You mentioned cryptocurrency mining. Obviously, it's a big. Turns out to be, while I think most cryptocurrencies, I guess, have moved on from CPU or even now GPU-based mining. It is a great host for USB devices. I know that, for Bitcoin mining, you tend to do it with ASICs, with USB-attached ASICs now, but you do need something to plug the USB ASIC into. And Raspberry Pi is one of the most cost-effective and energy efficient. I mean, obviously, there are a lot of challenges with energy efficiency around cryptocurrency mining. But at least if you're using a Raspberry Pi, it means that your host PC isn't sat there eating 100 watts. So that's nice. So the interesting thing really for me is how I don't know all the things that are happening with Raspberry Pi. There was a period when I did early on, and the interesting thing is every day I meet a new application of Raspberry Pi that might have been going on for 5 years and that I've never heard of before. So that's quite an exciting position to be in.
Right, yeah. I mean, to be honest, when I was doing my university postgraduate degree, I did a autonomous electric vehicle with Arduino, and it was trying to avoid obstruction and then map the whole area, and it was a really cool, fun project, and I used Raspberry Pi to do it. So it's just amazing that how sort of flexible it is, how compatible it can be for any projects, and you can create so many things with it. It just enables. It doesn't restrict your project.
It's a tool. It's a piece of glue, a piece of Lego. It's a thing that sticks other things together. It's a thing that sticks together the physical world and the networked world and the computing world. And I don't think we appreciated that would be its effect early on. But people love general purpose compute. We were a general purpose compute company. We make obviously the third most popular general purpose computer ever, after the PC and the Mac. It's more popular than any of these, the 8-bit architectures or the older architectures. And people love low-cost, energy-efficient general-purpose compute. So it's a fun place to be. It's a fun space to play in.
So at the outset, Eben, you try to make sure that kids learn how to code because you thought of it as a big problem. Why do you think that was the case in the UK? And do you think that that problem has been solved now thanks to Raspberry Pi?
I think it's probably easier to ask why there was a period when it wasn't a problem. What was going right before, and of course that's the home computer revolution. So our idea really was, and I think that it's been borne out. It's still a hypothesis, really, but I think we're close to proving it. Was that the existence of programmable home computers in the 1980s incubated a generation of enthusiasts, of young people, not just children, but a lot of children who were excited about computers. And then those machines went away, and then the students went away. So do I think the problem's solved? If you look at Cambridge's application numbers, we had more applicants to computer science last year than we've ever had. So more than we had in 1999 at the height of the dot-com boom. We had, I think, 2 or 3 times as many as we had in the late 90s. So that's great, right? So I think, but it's not just us, right? That's us and a bunch of other organizations all trying to solve the same problem. A couple of them, Code Club and Coder Dojo, big networks of after-school clubs. We actually merged the foundation with those organizations. So while you have these other brands they're separate brands, but they're actually part of our organization. So, but then there were also organizations doing great work that aren't part of the Raspberry Pi Foundation. So, but I think we've been an important part of this coalition. So I think the problem is a bit solved. I think you can never really solve it because you always find new things you want to solve. So, do we have the right proportion of women? Do we have the right proportion of people from different ethnic minorities? Do we have the right proportion of people from different social backgrounds? One of the wonderful things about computing is hobbyist computing and the games industry in particular, actually, is it offers people with non-traditional, unconventional educational backgrounds a route into white-collar employment. So you don't need to go to university to be a good computer programmer. I'd always advocate that people should get probably a degree level qualification at some point in their lives is a good idea, but you don't have to kind of be great at school and then go to university when you're 18 and then do 3 years of computer science and then become a computer programmer. You can become a computer programmer when you're 14 years old. And maybe by the time you're 25, you might be thinking, wow, and I had this actually. I went to Cambridge and studied physics, and then I started my first computer company, my first startup. And I became aware that the people I was hiring had I could program a computer, but I was aware that the people I was hiring had some other skills that I didn't have. And so I went back to university for a year to study specifically computer science in order to rectify some of these gaps in my knowledge. So, if you've started as an 18-year-old in an apprentice engineering role, you're probably going to want a degree at some point. But So computing is exciting because it gives those people a route into a profitable, enjoyable career. So you see, there's always this question of like, are you solving it? Are you making life easier for people who look like me? My father's an English professor, right? So you're making life easier for people who look like me. And that's fine, but life's already pretty easy for people who look like me. The gender thing is the most obvious one, where there is a shortage of women in engineering. It's getting simultaneously better and worse depending how you measure it, and so there's always work to do. And then, of course, you've solved the problem for Cambridge. Do you want to solve the problem for Imperial College? Do you want to solve the problem for all universities in the UK? Do you want to solve for all universities in Europe? For all universities in the world. So there's always, whatever you do, there's always more stuff. But we've had a good go. We've made some good progress.
Yes, absolutely. I mean, in a lot of cases, these are measurable progresses that was made, and it is something to be proud of, definitely. And no, you're right. I mean, there is a lot more work to do in many aspects of the social structure. But yeah, no, we just have to carry on and keep going. Um, but yeah, I mean, in terms of making computing more accessible to all kinds of people, all different people from different backgrounds, it's really important. And one of the things that I feel like we should be doing is, in various organizations we always have the IT department, or we whenever, and even during the education system, IT or computing is like a subject that you choose, whereas yeah, some of the common subjects are taught from very early stage in elementary school or high school. um, IT or computing should be one of those basic subjects in life that you need to actually know to sort of just navigate in life. And that's probably one of the things that would make this journey a little bit
Yeah.
advanced.
It's a fascinating. I mean, it's a fascinating question, right? Which is, yeah, where do you put computing in the hierarchy of things you learn? Do you put it alongside science, or do you put it alongside maths? Do you put it, alongside maths and reading? Is how foundational is it? And I mean, I'm inclined to think. I mean, obviously, every subject will bid to be a foundational subject, a mandatory foundational subject. I think there's a strong argument for some aspects of it being foundational. I mean, slightly foundational in the sense that maths and computer science overlap a lot. And you can there's an argument that the way, Conrad Wolfram makes this argument very powerfully. He's got a book, The Maths Fix, out last year, and he makes this argument very compellingly, which is that a lot of the ways we do maths are pre-computational, and therefore, if you teach someone how to do long multiplication, how useful is that in a world of calculators and spreadsheets, right?
Yes.
And you have to, if you want to justify teaching someone long multiplication when there's a computer that will do it for you, you kind of have to somehow argue that it teaches you something important about what multiplication is. The process of learning a hand mechanism for doing multiplication teaches you something about multiplication. And I think Conrad's very unconvinced, very unpersuaded that this is the case. So there's you can sort of make an argument for moving some of the maths time in your curriculum meeting. I think you can also make some sort of argument about civics as well. You can make some sort of argument about moving critical thinking into computational thinking. And there is the thing about computer programs is they work or they don't work. they of course you can't prove whether they are going to work, but they work or they don't work. It's a very binary world, and you have to think clearly. And the computers are stupid, right? They only do what you tell them to do. If you tell them to do the wrong thing, they'll merrily and at 1 billion cycles per second do the wrong thing. And so you have to think very clearly about what it is you want to do. And I think there are many circumstances at the moment in which, outside of computing, where perhaps people need to be taught how to think properly.
Analytically.
Yeah, analytically, analytical thinking, critical thinking, and I think that computing is engineering actually, but computing, because computing is a quite an accessible branch of engineering, is a good life skill because it strips away the illusions. You can't.
Yes.
If you have illusions, then your program crashes or your bridge falls down. So I think it's foundational. I think you've got to be careful because, of course, as I say, everyone will bid for foundational status. But I think there are aspects of it, maybe not the detail, but some of the high-level stuff which are foundational and should be taught to everybody.
Yes, yes, absolutely. I mean, I would passionately argue that it is foundational. At least some aspects of it, you can at least start the education from from quite early stage, because the way computing is now integrated within every stage in everything that you do in life. There is something you are definitely being subjected to computing either by having to use it, or whatever you're using, the background of that product or service has computing in it. So absolutely, I think the analytical thinking and all the other benefits that comes with this computing education is actually quite foundational.
So for
Um,
I wanted to ask, I mean, we talked about Raspberry Pi, BBC Micro, and Arduino, and Arduino was launched way before. So did Arduino actually inspire or the thinking? Because you mentioned that the first Raspberry Pi was based on a microcontroller version. So was
Mm.
Arduino responsible for motivating what you were doing?
I don't think it was early on. I think we developed kind of independently of Arduino. The Where it was motivational was once we started once we started making some progress towards launch, it was very encouraging to us to see the engagement that young people had with Arduino as a platform, um, because we'd been kind of on our own, kind of plowing our own lonely furrow. And then I went to a maker fair. I mean, for me, I remember going to a maker fair in New York in the autumn of 2011 to demo an early Raspberry Pi, and we had it was a kid there who had had a doll's house that he had automated using Arduino, and I was 11 years old or something. And I remember thinking, well, that's quite a hard platform to program. You program an Arduino, an original Arduino in C.
Wow.
And the kid had been programming in, I mean, it's a sort of stylized dialect of C, but it's still C. And this kid had made incredible progress. And I was like, ooh, okay, there is a future for there is, because it's been, if we make our hardware, maybe kids won't care. And that was probably one of my, so a lot of my early engagements with involvement with Arduino were kind of around getting some of these proof points that young people, even with a platform which is a proper full-on embedded system like an Arduino, children will engage with it if it allows them to do things that they find meaningful.
Okay. And I mean, when we look at microcontrollers and then the general purpose computers, I mean, to build a Raspberry Pi, you have to first start on the design board, like what should go there. So do you have like a process like what should be there in the Raspberry Pi and what should not be? How much processor should we add, RAM, ports? Because I think
Yeah.
those are those are kind of important, right? From a I don't know, feature point of view for the users or customers that you're trying to target.
yeah,
Right.
how do you decide the limit? Because
Uh,
obviously
yeah, that's
in
it. Engineering is only interesting if there are limits, right? And of course, the ultimate limit for us is cost.
ah,
And so you can see to some extent, look at a 2012 Raspberry Pi and a current Raspberry Pi. Literally, the only qualitative change um, is wireless, which we added in 2016. So with the last time we added an actual, honest to God, new feature to a Raspberry Pi was 5 years ago. Now we make the features better. We put more RAM, faster wireless, faster USB, faster Ethernet, faster processors, more graphics capacity, high resolution screens, more screens. But those are all quantitative things. Those are all just taking an existing feature set and turning the dial up. Um, uh, so so a couple of things. One, how do we decide what to put in? Well, basically, we only put in things which are going to be useful to all of our users. Wireless is the only non-core, non-original feature that ever made that cut. So nothing else ever does, right? So there's no AI acceleration. There's no dedicated AI accelerator. There's no secure crypto enclave. There's no analog to digital converter. There's no real-time clock. All of these things. You can get all of those things for Raspberry Pi, but they are accessories to Raspberry Pi. They're not in the core product. And the reason for that is that you don't want to tax every Raspberry Pi. If you have something that 10% of people want, you don't tax everybody to pay for a thing that only 10% of people want. You can see it as dividing through by the fraction who want it. So if I have a 50-cent feature that 10% of people want, I'll put it on the board, but I'll think about it as a $5 feature. I'll divide through by a tenth. And so only features like wireless, which are relatively affordable to add and which everybody wants, make the cut. So that's the kind of what features. In terms of how far did we turn the dial, we just turn the dial as far as we can every time, subject to staying within $35 for our baseline product. Occasionally, we aren't able to do things we wanted to do when we launched Raspberry Pi 4. Our $35 product was a 1 gig product, and
Yes.
fine, but 1 gigabyte of RAM really sells. Raspberry Pi 4 is awesomely powerful, and 1 gigabyte of RAM really sells that power short. And so what was exciting for us, we knew RAM prices were coming down, but they didn't get to where we needed them to be in time. Great thing for us was about 9 months into the project, we were then able to bring the 2 gigabyte product down from $45 down to $35. And the nice thing about that was that happened just in time for the pandemic. The 2 gig product is the one that's the lowest memory variant that's really usable as a full-featured home PC. We were able to bring that to an attractive price point just in time for for everyone to need home computers. So that was a good outcome.
So, I mean, you talk about cost a lot, and I think it's a very important factor to consider, especially entry to computing. I mean, people who want to learn, especially people from Asian market, African, American, where they can't actually afford a very expensive computer. So, how do you actually try to keep the cost low on a Raspberry Pi?
Well, we don't put too many features in.
Okay.
The sort of things I just mentioned help. Um, the other obvious ones, one Moore's law still has some legs in it, so you do still get a little bit more performance. We've gone from 256 meg to 2 gig of RAM in the $35 variant in 9 years. That was 8 years. Yeah, that was 8 years. So that was quite good. That was quite good. So you get some benefit out of Moore's law. The other thing, of course, is we invest an enormous amount of money in manufacturing technology. So
Okay.
it's a very highly automated manufacturing process. We do not have many people involved in making Raspberry Pi, so that's important. We work with suppliers to make sure we get exactly the chips we need, exactly the silicon we need, exactly the connectors we want, exactly the PCB technology we want. So there's a lot of effort goes into making sure that everything just works, so that everything is just as it should be, and we don't end up having to throw dollars of silicon at patching things we forgot. So we made a lot of Raspberry Pis, and so that means that we have a lot of manufacturing experience, take some cost out. B, we have a lot of experience as to what needs to be in these devices, and that means we can spec chips very accurately, and avoid sort of extra components on the board. You look at a Raspberry Pi 4, it's a very simple product. It
It
doesn't have
is.
a lot, right? It's got a power supply, it's got a SoC, main processor, it's got memory, it's got a USB. Uh,
HDMI.
yeah, it's got a USB chip, it's got a gigabit Ethernet chip. So it's got basically 5 pieces of silicon on there, and they're supporting passives, and then a bunch of connectors. So it's a very cost optimized, efficiency optimized design. And that's what we always do. And we talk about the BBC Micro, actually, the dirty secret of Raspberry Pi, the sort of dirty realization of Raspberry Pi. We have a lot more in common with the Sinclair Spectrum. The other great computer, the other great Cambridge-based computer of the 1980s. That was a cost-optimized design. We're a cost-optimized design, but because we have where I think the Spectrum was a compromised design because of its cost focus. Over time, what we've been able to do is exercise so much control over the silicon that goes into the Raspberry Pi that we've been able to get all of the benefits of Sinclair-like cost optimization with a kind of BBC Micro-like feature set. But certainly the philosophy, the organizational philosophy, is very Sinclair, actually.
Okay. And then what about the Raspberry Pi OS? I mean, how does that fit into the overall cost? Because that's a separate from the hardware. I mean, I think the foundation focuses on the hardware side, but what about the software side? Who actually pays for it, the development, the maintenance, and the features?
We do.
You do, okay.
Um, we do. So this is a Debian-derived operating system for a variety of reasons. We don't use the Debian, at least for our 32-bit world. We don't use the Debian repository system. We have a rebuilder, a chap called Peter Green, rebuilds the Debian world in a way which is compatible with the chip that we use on Raspberry Pi 1 and Raspberry Pi 0.
Okay.
So that's a uh, so we benefit enormously from Debian's investment in developing a well maintained, well thought out, well maintained Linux userland. We obviously benefit from the kernel, all the investments that everyone's makes in the kernel, and then we take the kernel and our downstream patches. We take Debian as rebuilt by the Raspbian project and our own additional packages, our own user interface customizations. We assemble those together to make a Raspberry Pi OS image. Currently a 32-bit image with a 64-bit testing image. One of the big things that will happen to us over the next year or so is we're likely to turn up the focus on 64-bit and turn down the we need to move to the glory. We've been shipping Raspberry Pi 3 was our first 64-bit product back in 2016. We still ship a 32-bit userland. We had 1 gig of memory on the platform, which we did until 2019. That made a lot of sense. I think increasingly to get the performance out of these higher end platforms that we ship now, we really do need to go 64-bit.
Amazing. I mean, that is a lot of information to be honest. I don't know if I'll remember all of that, but you've obviously grown with it, so you know exactly the journey you have taken, etc. I mean, you mentioned AI a bit ago, so I'm just thinking, how do you have like a add-on with Raspberry Pi? Is there like something that you add on that does like enables? Sorry?
We don't, but other people do. And this is really the story of Raspberry Pi, that accessory vendors grow up around a platform.
Yes.
And there are a lot of those accessory vendors who are very small or started very small and have become big. Mom and pop companies that have had some successful accessories and have reinvested. Cases were a very early one. People made plastic cases for the Raspberry,
Yes.
and people kind of invest and kind of climb the tree and make progressively more complicated accessories or progressively better designed accessories. In the case of AI, actually, the little company that does most in this area is a company out of California called Google. You may have met them. They have a program called Coral that makes AI acceleration hardware based on their in-house TPU designs. And you can get a USB 3 dongle that you can attach to a Raspberry Pi and particularly Raspberry Pi 4, which has USB 3, and get really nice energy efficient acceleration. Of course, you can run a lot of machine learning stuff on the Raspberry Pi itself. Is actually very, very powerful, with quad-core A72 at 1.5 gigahertz. That's an enormous amount of general-purpose compute. I guess where these accelerators are helpful, they do give you more total compute if you want it. But the big benefit they have is they give you lower latency, and they tend to give you better power consumption numbers. Your energy per operation is much lower if you're running on dedicated hardware.
Yeah, absolutely. I mean, obviously, when we say ASIC nowadays, it's very much intertwined with cryptocurrency. But ASIC is application specific by its name. So there could be many application specific, many different applications and many different ASICs for different purposes. And one of the ideas I had actually is to have different ASICs which would do different AI algorithms, like artificial neural network. There could be an ASIC which just does that kind of calculation, or a genetic algorithm could be another one. But I don't actually know whether these kind of ASICs exist already. But I just thought that would be a very cool add-on to have. But I haven't actually found any.
So Coral, if you just Google Coral, you'll see that it's a neural network accelerator. I guess a convolution accelerator. Most of these things are convolution accelerators. They do dot. Obviously, Google have an advantage because a lot of the basic research that in this area comes out of Google, and so they're able to design their hardware to support what they think the future holds for neural networks. So that's in terms of the layer structures and activation functions and other bits and pieces that people are always eking this stuff out, and people do it initially always in the GPUs. They do it in the context of GPUs because they're programmable. But then once things stabilize, as Bitcoin example is a really good one. Once things stabilize and become a fixed target, then they're very vulnerable, very amenable to ASIC acceleration. And ASICs is great. I mean, everyone should make ASICs. I make ASICs. I like making ASICs. Although I'm a software engineer, I actually ended up being a silicon engineer for a long time. Kind of, I'm a silicon engineer. I love making chips, and I think everyone else should do it as well.
So, I mean, before you started Raspberry Pi, were there actually any inspirations or role models or mentors for you to actually, I mean, help with the Raspberry Pi project?
Not the Raspberry Pi project, really. I mean, that was fairly standalone. I mean, obviously, we all have mentors who've helped us through our careers, and obviously, I have a fair few of those from childhood, I guess, childhood onwards. I mean, I've always found business interesting. Actually, I've always kind of been drawn, I think, to the business aspect of computing as much as the technical aspect. I started my first company when I was 21, 20.
IdeaWorks 3D, right?
That's the one.
That's
Yeah.
one, yes.
Well, I think they're just about still in business, actually. And that was always very satisfying because I left that company after about 3 years. But what was really satisfying about it was there was a real sense that interesting. They were doing work and they were creating employment. And long after I left, they had 50 to earning good salaries, paying their mortgages, paying tax. And it was very satisfying. I would get up every morning and not every morning, once every 6 months, you got to get up and go on the web and look and see what IdeaWorks have been doing. And that was very exciting. I think they're still around. So I've always enjoyed doing basic technology and deep technology, but I've always enjoyed as much the businesses you can build around it. And of course, ours is a wonderful industry for that, right? I mean, there's a lot of people who did basic. There's a lot of, I mean, obviously Bill Gates has been in the news the last couple of days, kind of sadly. That's somebody who was a kid, right? He was in at the start. He's 60. This is a guy who was in right at the start. This letter that he wrote to Paul. I always said email, but of course letter that he wrote to Paul Allen saying it's starting the thing we talked about, and we're going to miss it. And so you have people who did really interesting foundational work, writing BASIC for the Altair 8800, and then built businesses, big businesses, good businesses on top of it. So there's no shortage of role models in our industry.
Absolutely, absolutely. And then, I mean, when we look at, sorry?
I said to my wife the other day about Gates, I'm like, he gave up running Microsoft when he was about my age.
Yes.
And I said, how did he do that? Running Microsoft. And she's like, oh, not everyone's like you. I'm like, yeah, but it's Microsoft. I run Microsoft now, and it's a much less, I mean, it's a fine organization, but I mean, I'm sure it's much less interesting than Microsoft was at the point where Gates stopped running it. How did he do that?
Yes.
Like, how would you go, I'm running Microsoft and then tomorrow I won't be running that? That would be insane, right? So I have enormous respect. I have enormous respect for someone who can do that sort of thing and then walk away and then go and do something else, which is of course what he did. But it's interesting.
I think it comes down to those problem-solving skills that he was trying to solve some problem when he was young, and when he had enough money, then he was trying to solve other problems in the world that he could not ignore anymore, which he felt, I think, was the right thing to do.
So an article today said 6 million people, 400 million vaccinations. The Gates Foundation's biggest vaccination program. 400 million vaccinations, 6 million deaths prevented. And okay, that is probably more interesting than writing an operating system or still, you think 6 million people, it's like the population of Central.
Yes, exactly.
Because it's incredible, isn't it?
And I mean, coming back to Raspberry Pi, I mean, we keep talking about GPIO, the general purpose input-output pins, which have actually made Raspberry Pi the reason for its real success. So was it actually originally planned to be put in, or because you talked about microcontrollers, you talked about building a small computer, $35 computer, and then you have those pins. So how did those pins come in the project?
It's because I didn't design the PCB, so I couldn't veto them. Pete Lomas designed Raspberry Pi. One of my co-founders designed Raspberry Pi 1, and he said, well, look, we have all these GPIOs on the chip. We should bring them out to a header. And I said, well, that's ridiculous. Nobody's going to want to do that. This is a computer. This is for writing software on, because I'm a software engineer, right? And Pete's an electrical engineer. And so he said we should bring them out to a connector, and I'm like, right, you design the PCB, you do whatever the hell you want. And he did, and of course it's the backbone of our success. So don't listen to me.
Yeah, because I mean, you can connect so many things with the input output pins, and it's just crazy.
Yeah, it's fine. I'm aware of it. Yeah, so it's the thing, right? Don't listen to me. It's always it's a challenge as you when you run an organization like this that has very, very many very talented, smart people in it. How often you want to demand that people just listen to you, and the answer is almost always never. But I mean, it's something I find in terms of a personal journey, something I find very difficult, right? Because the answer isn't never, actually. If it's never, then you're not. What are you even for? So the answer is sometimes. And that's a very different. It's very different. Always and never are very easy settings of the dial. Sometimes is a funny setting in the middle of the dial, and I don't always get it right at all. But it's probably you think about why I keep doing this, actually. Why do I keep doing this? Because I'm sure I could go and do something else, probably not on the Gates Foundation scale, but I could go and I'd go get another job. Why do I keep doing it? I keep doing it because actually the setting of that dial is fascinating. There are a number of personal growth, personal learning experiences that I continue to have, and I don't think I'm anywhere near getting all of the growth out of it, or all of the personal satisfaction out of it. Learning to adjust that particular dial is fascinating, actually, to me. I enjoy it.
So, I mean, obviously this is a very exciting project to work on anyway, but is there any other projects that you're also kind of side projects that you're working on, or you have plans to start maybe during the pandemic?
I have two small children. So yes, I am.
All right.
I have two small children. I have enough side projects.
And are they learning Raspberry Pi?
Not yet. No, neither of them. But I'm sure. I hope they will one day. But I have a 4-year-old and a 1-year-old. So I have a daughter who was 4 2 weeks ago, and I have a son who is currently 0 and will be 1 on Friday, and a lockdown baby.
Yeah, that wouldn't give you any more time for any other projects, and meaningfully so. I mean, you probably would want to spend these times.
I do a little retro computer programming sometimes. I do even less of that than I should do, but I do a little bit of. There's a thing called BBC Microbot, which is always worth a look on Twitter. It's at BBC Microbot, and it's a emulator for the BBC Micro, and you tweet it a basic program, and it runs it on the BBC Micro and sends you a video of it running. And that's something that I indulge in from time to time, because I think it's a very constrained problem, right? 280 characters, and you have to do something interesting. Really, go and check it out. So some little constrained retro programming is interesting always because of constraints. And that's kind of useful if you're very busy, because it means that it limits the amount of work you can do. So I've written the occasional game for machines that I grew up with, and that's a lot of fun. Shader Toy is fun as well, actually. Shader Toy, if you come across that, lets you write OpenGL shaders in a web browser and then look at the results. And that's another one way you can do 5 minutes of work and get something pretty, which is always very satisfying.
Yeah, the only thing retro I do is play the retro games from 1990s and the ones that I grew up playing, and they are still nostalgic, but still so much fun.
What was your platform of choice when you were young?
So I don't know if it's popular worldwide, but I used to play this game called Cadillacs and Dinosaurs, and
I've heard of that. I don't know what it is, but I've heard of it because it's like Raspberry Pi. It sticks in the mind,
Yeah, there would be many dinosaurs, and you choose your characters, and then you beat them and go to the next levels and stuff. Then there was another thing called King of Fighters.
Yes, I know that. Yes.
I mean, I was so good at it. I mean, it's a shame there was no worldwide tournaments like on online games there, because I think I would have been beating everyone then. But yeah, it's still fun, nostalgic and fun. I think a lot of the times, uh, millennials are actually, a lot of the times they are driven to go back to their childhood, and a lot of products are nowadays are you know focused specifically to tap that emotion in millennials. And yeah, I mean, that's my retro uh, projects that I sometimes do.
So, Eben, I mean, we talked about Raspberry Pi, BBC, Micro, and other things. So, and general purpose computer, Raspberry Pi, third most selling compute platform in the world. But now you have smartphones,
Mm.
tablets, and they have the same chipsets like ARM. They are all ARM-based processors.
Mhm.
The latest Raspberry Pi 4 has Cortex A, I think Cortex A53, and the latest
It's A72 in a
A
Raspberry 4 is an A72.
A72. Okay, and the latest Snapdragon chipsets shipping this year on the smartphone is Cortex A78. So you're not that far off,
No,
uh,
getting
and
closer.
you close, but so how do you? I mean, and kids are obsessed with smartphones now these days. I mean, parents they normally indulge kids with, okay, go watch something on the TV or play some game on the phone, etc. So how do you tap those kids and bring them to Raspberry Pi? I mean, what are the kind of things that you would need to do to attract them to this side?
Um, I actually think tend to be attracted to it anyway. So that's been the surprising realization is that you don't have to compete very much actually.
Okay.
Provided because the stuff you can do with the Raspberry Pi is interesting. Kids have problems, and Raspberry Pi is a machine for solving problems. So, everyone has something they want to do, an art project, or want to take a video of what animal is wandering around in their garden and setting off the security light in the middle of the night. Every kid has something they want to do, and if you make a product that helps them solve that, it doesn't matter if the alternative is that they can sit in front of a television and watch a movie or sit in front of a games console and play a game. It's still an interesting part of their lives. So I think that's fine. I think it is important that it's always been important to us that the platform is reasonably powerful, that it doesn't feel like a piece of retro hardware, that it's, you can, if you want to watch YouTube, you can watch YouTube on a Raspberry Pi. If you want to play computer games. If I've got a regret about the platform, we will try and do something about this. If I have a regret about the platform, it's that there isn't a computer games industry around it. With 40 million units sold, there should be a computer games industry, and there isn't, and that kind of sucks. So that makes me sad. Because I think that would make it a more attractive platform in the same way the machines you had when you were young, machines I had when I was young, they were attractive in part because they had good computer games on them. I think if there were
Yes.
good computer games on Raspberry Pi, that would make it a more attractive platform to children.
Well, this is where the retro games could come in handy, because they require less power. Absolutely. And,
It can be hard for us to promote them though, because of course always an IP concern about retro
yes.
gaming, and I don't personally believe that it is a moral concern. You sort of think about things that are legal concerns and things that are moral concerns. If someone wrote a game 30 years ago and then they abandon it and they don't do anything with the IP, it's hard to argue that it's immoral for someone.
Well, to be honest,
Who's losing out? If it gets a little bit more complicated, I think, when you have devices like the there are now retro consoles, the mini NES, mini SNES, devices like that. So you think, well, do the games on that still have some residual value in them? But anyway, it just makes it hard. The messaging is hard around retro games. There are, of course, some very generous retro game authors who have taken the positive step to put their products into the public domain. And then there's sort of a middle ground of people who clearly don't care about whether their products are in the public domain or not. Maybe people have forgotten I even wrote them. And then, of course, then there's that hardcore of games that are still considered live IP, where the brand holders are more protective. But yeah, you're right. I mean, it is a use of the platform, and to the extent people do it responsibly, we're very much into it.
Yes, absolutely. I think that one of the important things to think about is that retro games, while being retro, and while the newer games have all these advanced 3D graphics and all, the games from 90s and early 2000s were still fun, and they are enough fun that I would still play them right now. So, without the need for all of these advanced graphics and everything, which requires a lot higher processing power, we could create new games so it would look and feel like retro games, and that are easy to play in a device like Raspberry Pi. I mean, they're not in any way less fun. That is my point. So ultimately, you play games as an entertainment, and it can easily be achieved with computing power that is available in Raspberry Pi.
Yeah, we used to. I mean, I was involved in the GPU design team that designed the GPU in Raspberry Pi, and of course, we used to joke while we were working very hard to design a great GPU for mobile devices that actually all anyone wanted to do was play Tetris.
Yes.
You look at where was the money actually going? At least at that point in mobile gaming, all the money was going to Tetris, the guys who own the Tetris brand, and so actually, all you would need to be able to do is move a few squares around the screen.
And coming back to, we've covered smartphones and tablets. Now we have this Intel NUX, the next unit of computing. Do you think that Raspberry Pi is actually competing with those platforms as well?
Yes. I mean, it's a PC, right?
Yes.
So it competes with anything that's a PC.
This is a question from one of our listeners as well. Basically, why is Raspberry Pi better than an NUC in which scenarios?
A lot lower cost and a lot lower power consumption. It's smaller, and it has enough compute. I don't know if you can still get the Atom-based NUCs. Their performance is really often quite terrible, and so it's not going to compete. I think you can put quite a beefy Intel processor in an NUC, and then of course you'll get good performance. But it's very competitive with the bottom end of the NUC performance range, but at a fraction of the cost. I bought NUCs in the past. What did I buy one for? I wanted to send somebody what I've used them for is if I need a Windows environment and I want to send somebody a canned Windows environment. So I had to send somebody a platform they could use to debug a Raspberry Pi, and the Raspberry Pi debugger runs on Windows. And so what I did was bought an NUC, installed Windows on it, set it up with a Raspberry Pi to debug, screwed down to a plank, put a plank in DHL and sent it to the person. And then that removes any configuration management issues. Sort of here's a 100-line setup script that you have to get exactly right, otherwise it doesn't work. It's like, this worked when it left my desk. Here you are, plug it into a monitor, plug a mouse and keyboard into it, and this works for you as well. So that's useful, if you want a little canned x86 environment. But I sort of don't, particularly once we grew gigabit Ethernet and USB 3, I think we sort of probably retired the last few things that it made more sense, other than Windows, that it made that where the NUC made sense in our space.
Right. Okay. Great. Sorry, Amit.
Okay, I have a question. So, I was reading your foundation website, and there is an Astro Pi challenge, and NASA recently sent a rover to Mars. So, the Pi has gone to International Space Station. Everyone knows that. So, is the Pi Foundation now targeting Mars as the next big endeavor?
Mail Elon, and I did say, if you want to stick one of our Raspberry Pis on your, they were going to do. They had a platform called Red Dragon that they were going to do for a while, which was an attempt to land a Dragon, a V2 Dragon on Mars. And I did say, well, look, if you can give me 10 grams of mass budget and a USB port, we'll do your Astro Pi on Mars. Your code in space is such a powerful brand for kids. The kids love that. And we were like, well, yeah, your code on Mars, that'd be kind of fun. But yeah, I didn't hear back. I think he was busy doing something else. I don't know what. Yeah, anyway, I would love to see a Raspberry Pi platform, either the big Raspberry Pi or of course the Raspberry Pi chip stuff, the microcontroller that's in Raspberry Pi Pico. I'd love to see that stuff outside low Earth orbit. It's only 200 miles away. It's only about as far away as Leeds. Right? Oh, it's Edinburgh, maybe, but it's not that far away. I'd love to see something on the moon or in interplanetary space or on Mars.
So I mean, Raspberry Pi is good when it comes to low power consumption, but what about reliability? Because when you do outer space stuff, reliability becomes a major factor. So how often I mean, I've used Raspberry Pis and they are not generally okay, but do you think reliability is, I mean, I'm not sure about Raspberry Pis, but is reliability a factor when it comes to going to outer space? And is Raspberry Pi quite reliable when it comes to long-term space exploration?
Low Earth orbit is not a particularly high radiation environment. It is a high radiation environment than the Earth's surface, but it's not a particularly high radiation environment. You do get single event upsets. I think we've observed that the Raspberry Pi is surprisingly reliable, like very, very reliable. I'm sure we have had things that we would attribute to single event upsets in the history of the Astro Pi program, but only a handful. It's certainly not epidemic. One of the things, of course, is that because we tend to be very efficient platforms, our chips tend to be very small. And that means their cross-section for being impacted by cosmic radiation is low. And so if you're kind of, it's not a correct model, but if your model of when does your system crash in a high radiation environment is as soon as you get hit by anything, you crash. If you're smaller, you get hit less, so you crash less. And certainly Raspberry Pi 1, which is what's on the station at the moment, it has a 30 square millimeter chip in there, not all of which needs to be working. So it probably has about 10 square millimeters of target of area that you really don't want to hit with a high energy particle, plus the RAM, which is probably another few tens of millimeters. So it's very small compared to the crew station laptops, which have big Intel cores in and large amounts of RAM and stuff. So there are no specific radiation hardening features to the platform, but it turns out that smallness actually goes a long way.
It's interesting. And
outside low Earth orbit, I think your mileage may vary quite a lot, actually. The Van Allen belts are awesomely full of high energy particles. You want to get through them as quickly as you can. Interplanetary space is fairly full of high energy particles, particularly from time to time. So I would be interested to do the experiment. I would probably be unsurprised if the thing was I would expect the thing to be very, very reliable even under those circumstances. Probably not to aerospace grade, but certainly to the grade where you could do something useful. And I'd actually like to fly RP2040, the microcontroller platform, because that's only a 2 square millimeter piece of silicon and has no external memory. And so that feels like a platform which, from a cross-section perspective, should actually do pretty well.
wow.
Right. Great. Coming back to us, so you mentioned one of the things that you're really inspired to do is to get younger people more into coding and computing, etc. So is there like a knowledge base or a website? I mean, obviously there are many websites which will teach you how to code, and many really good websites and videos and everything. But I mean, do your foundation have a website which has like a knowledge base or like a step-by-step of various cool projects that was done by Raspberry Pi?
If you go to raspberrypi.org,
mm-hmm.
you'll see that at the top of the page, I'll do it now, raspberrypi.org, at the top of the page, over on the right-hand side, you have a link called Learn, and then there's a link under that called Guided Coding Projects. And that will take you to... So we have a bunch of programs. Obviously, you saw Astro Pi. We have Digital Making at Home. We have a large collection of guided coding projects. Some site projects at raspberrypi.org, and you can really pick what you want to do. We'll walk you through a project. It's an important part of the offer. Obviously, it's the foundation's offer, not my offer. This is well, the thing I run is Raspberry Pi Trading, which is the engineering subsidiary of the foundation. But the foundation does enormously successful work in that kind of informal, self-directed space, but also a lot of work in the in the formal teacher training as well. Because we talked about role models. Yeah. Teachers are role models, right?
Teachers, yes.
If you have a problem when you're a kid and you're learning to program and you've got a problem, who do you turn to? There has to be somebody you can turn to. And of course, I was lucky because, I had family friends who I could turn to. But it was still the case that teachers were a very important part of that. And so making sure that teachers are properly trained to support the young people who they are responsible for is a very important part of the foundation's mission. But so the self-directed stuff is where we come from. And therefore, you'll see there, when you go on the website, you'll see there's a lot of focus on that.
That's amazing. Yeah, I mean, intentionally. I mean, the point of this was to basically, highlight to our listeners and viewers, audience. If you guys are interested in any kind of Raspberry Pi projects, definitely head over to the website Eben just mentioned.
And Eben, coming back to role models again, I mean teachers. I mean, I was looking at the foundation website yesterday itself, and I mean the whole idea we both started this tech podcast was to educate people. I mean, people who are not aware of technology, not aware of Raspberry Pi. Maybe there might be some people who are not aware of Raspberry Pi. Just talk about it, give them that exposure, and then they can pick it up. So we are trying to do our bit through the podcast. But suppose as an outsider from a public, I want to contribute to the foundation. How can I do that if I'm not a teacher? Because I saw that, okay, you have to be a teacher, and then I can get some courses done, and then I can go through the things. But as a general public, how do I contribute to the foundation?
I guess a couple of ways. Obviously, people can contribute financially. Should mention it.
Yes.
You can donate to it. But I mean, kind of from a practical perspective, people can volunteer to run clubs. Either code clubs or code dojos. So there's a wide range of volunteering opportunities. I always say actually people should consider volunteering in the sense of just helping kids who they know.
Yes.
That's not formal volunteering, but I owe so much to adults who took an interest in my interest in computing when I was a child. So people should do that. We do have courses. Obviously, the projects are available to people. You can do them yourself and learn and thereby be a better mentor to the young people around you. We do have courses which are available online, courses which are available to people who aren't accredited teachers, and you can do those and become a better mentor. Just know more stuff yourself. So there are a lot of ways of contributing, I think, that aren't. We engage with formal education a lot because in the UK, because it's a way of ensuring that every child gets a level playing field, gets the same level of teaching, the same base level of teaching. But all of the informal stuff, as I say, informal is where we come from. That's our original concept. And it's really important. And of course, it's incredibly important outside the UK in that we aren't scaled to engage with the German education system, the Australian education system, the Kenyan education system. We're not scaled to do that engagement. So to the extent that we make an impact outside the UK, it's either through these informal channels or it's through partnership. And that's a very important part of what we do, or both. So for example, Code Club, a lot of international franchisees who run their own code clubs. So it's called social franchising. It kind of brings the franchising model to the not-for-profit space.
Okay, and then I come from India. I grew up in India, and I always feel that teaching is quite important, especially to a younger generation, because they can actually change the planet in a much more meaningful way than maybe teaching adults things that they don't want to understand. So teaching is again, yes, it's a good way to educate the children. But then, what's the foundation's role in countries outside the UK or Europe, especially say in Africa, Asia, and Americas? Do you think Raspberry Pi has made that big an impact in those countries as much as you would like to?
I think there's a solid core of developed world economies where Raspberry Pi really has, if you measure it on a per capita basis, places like Germany Raspberry Pi is every bit as popular as it is in the UK. As a hobbyist platform, and also people doing our resources. We have a big translation effort. We have a big community. So we have on the commercial side, we translate some of our collateral. We license some of our magazine brands internationally. On the we have a community-driven translation effort that's translated our work into very, very, very large number of languages. So we do our best. I think there are enormous opportunities. If you look at like where do we employ people outside, where does the foundation employ people outside the UK? Republic of Ireland, because that's actually where Coder Dojo came from. So we have an office there that we got when we merged with Coder Dojo. We have a small number of people in North America. We have Raspberry Pi Foundation in North America. Challenge in North America is always, it's a big place, complicated place. From an educational perspective, it's actually 50 different countries. It's not a fully integrated. The idea of the United States as a single country is not quite the right abstraction. So it's kind of, you need to be big in order to have scaled impact. And that's always a challenge. But you had some great success there, run some great programs in North America and looking to grow that in the future. And then India as well. We have some people.
Right. I mean, this is... Sorry, this is very interesting because I'm actually I'm from Bangladesh, and I know for a fact that there are a lot of young people who are looking to upskill themselves by learning computing, but there isn't enough opportunity or there isn't enough availability of information. And
so this is one where now I do not know whether we have a code club franchise in Bangladesh or not.
There isn't actually. I mean, I have looked into it, and even the Raspberry Pi is not available. I mean, obviously, one of the main objective is to make it accessible through being cheap. And if you want to get Raspberry Pi in Bangladesh, you would have to pay like a really high price, same as like probably a laptop, and that is obviously very restrictive. And I mean, it just.
I don't. You're right. We don't have a. We do not have a. I'm interested. I'm a little bit. I have to say, I'm a little bit surprised that we do not have a. Neither do we have one in Pakistan either. Actually, we do in India, but we do not. But in the area with that, that's the only. Place.
Is there anything I can do to sort of bring Raspberry Pi in Bangladesh?
Well, I think that there are two aspects, right? There's the charitable aspect and the commercial aspect, where the commercial aspect has mission impact. So the commercial aspect isn't just about making money, because we don't really make very much money with a Raspberry Pi. It's about the impact that the devices have. So I think that in all of these places, the goal is to find entrepreneurial young people who are interested. Why is Raspberry Pi successful in the UK? In significant part because of guys like Jamie Mann, who runs the Pi Hut out of Haverhill, John Williamson and Paul Beach, who run Pimoroni out of Sheffield. Young people who are entrepreneurial and have built businesses around Raspberry Pi. So when we talk about succeeding we've just today had our first hire in Africa start, based out of Lagos. And what's his mission? His mission is to go and find Nigerian Jamie. His mission is to go find Kenyan Jamie. What we need is Bangladeshi Jamie. That's the mission, right? To go find people like that. So I don't know. I think what can you do to be helpful is if you know people in Bangladesh who are young and are interested in doing business, make them aware that there is an opportunity. Make them aware that there is a thing they can sell. In that kind of context, I really see it as being an entry-level computer, an entry-level PC. In particular, it's a thing that turns your television into a computer. So you plug it into if you already own a television, but you don't have a computer, the cheapest way to get a computer is to plug a Raspberry Pi into your television.
Oh, right. Okay. I mean,
that's the pitch. That was the pitch for me from my BBC Micro in the 1980s in the UK. The pitch was it turns your television into a computer. In Africa today, turns your television into a computer. Bangladesh Day turns your television into a computer. Lots of people have televisions. You end up with societies where many people have televisions and many people have mobile phones. Nobody has a computer.
Yes.
The Raspberry Pi is the thing that can talk to your television for display output, and it can talk to your mobile access, and it can give you an internet connected PC. That's got to be a business opportunity for somebody. And the success of guys like Jamie and Paul and John here in the UK shows that can be. So that's why I would say, find your most entrepreneurial friend in Bangladesh and give him my phone number. Be our licensee in Bangladesh. Anyway, take a Raspberry Pi 4 with you. Show it to some people. If people want to buy them, I mean, we've always said in these markets, we will, and this is currently something we are very live for us at the moment in Africa, in Nigeria and Kenya, is if there are people in a market that we don't serve who want to try and make it work, we'll move heaven and earth to get units.
But how would it work? Sorry, I think we're moving away.
Seriously. I mean, this is now a business. Is this a podcast, or are we?
It's a podcast because I mean it affects a lot of people, and people. I mean, we have noticed that people in Africa are listening to our podcast, so it
I'm
just
very
gives
happy
idea.
to talk about this because this is what people don't understand. It's like I believe these markets need Raspberry Pi.
Yes.
Yes.
We need the right people in these markets as much as these markets need Raspberry Pi.
Absolutely, and I mean, I know so many people. I mean, it's a very densely populated country, and one of the things you would, I don't know if you would agree, but I think intelligence in this is distributed evenly. That's why there, and
That's it, right? Think of all the Mozarts who died before there were musical instruments for Mozart to play. Think of all of the Bill Gateses who died before there were programmable computers, right?
And there are 20 million people in Bangladesh, and they're bound to be Einsteins that are not getting the tools and equipments that they need.
We talk about access to tools. There's a thing called the Whole Earth Catalog, which was a rather hippie. Whole Earth Catalog. It's worth, if you're not aware of it, it's worth a Google. So this thing was like like the internet before the internet. So it's like a book that has. Right. You want to buy a water filtration kit, so you big Californian hippie can go live in the hills and not get poisoned by the water, or a geodesic dome, or instructions for how to build a geodesic dome, or how to cure leather.
Right.
So this is big kind of like catalog of people who will sell you. Instructions or equipment to go be self-sufficient. Really, it's a very kind of 1960s American hippie thing, and one of their kind of mottos was access to tools. That's what we do. We give people access to tools. There are people out there who do not have tools, and we give them tools.
Yeah, I can imagine it would make such a big difference to the younger generation if they had something, as cheap as Raspberry Pi, because it would actually, I mean, if I convert $30 into Bangladeshi currency, that is actually accessible to many people, even lower middle class people. And there are many talented youngsters out there who are just looking for an opportunity like that. I'm actually very excited now.
The 2 gigabyte, the product for this market is there's an argument that the product for this market is the Raspberry Pi 400. So the Raspberry Pi inside the keyboard, because it's kind of a finished product. But that is a $70 product. There's, I think, a strong argument that really the platform for this market is the 2 gigabyte Raspberry Pi 4. It's a $35 product. It has everything you need apart from the obviously display, mouse, keyboard, power supply. So you have some accessories around it, but it's probably less than $10 worth of accessories around it to make it.
Yeah.
And then that's for someone who already owns a television and wants to give their child an educational platform. I think it's why we're so obsessed with $35. Like it is affordable for huge numbers of people all around the world. What are we looking for? We're looking for people who want to set up some local e-commerce and fulfillment capability. So fundamentally, what does somebody need to do in order to be a useful, approved reseller is the phrase.
Mm-hmm. Yeah.
These are the people who, while we were talking, I just went to our website and I selected one of my products and you can pick a country. And I said, I'm in, Bangladesh isn't on the list, right? To be an approved reseller is the person who services a purchase request that comes via our website in a particular country, right? So what does an approved reseller need to be able to do? Well, they need to be able to take orders and collect money. They need some e-commerce capability. They need some fulfillment capability. So they need to be able to do outbound and inbound logistics. So they need to be able to send packages to end customers in response to some e-commerce transaction. They also need to manage inbound logistics. That's getting units from Raspberry Pi. That is a very variable difficulty depending on what country you're in. Some countries make it easy, some countries make it hard. So if someone is in a market, I need to adhere to the pricing structure, right? So there's always a discussion about pricing, which is it's important it costs the right amount of money, and the right amount of money is basically $35 plus tax, plus reasonable shipping, plus import duty. So it's kind of if someone's charging 20% import duty and 20% VAT, the thing isn't going to be anywhere. In the UK, it's $42, right? Because we have 20% VAT.
Right.
It's inbound logistics and in-country logistics are obviously the kind of make or break in terms of whether this sort of thing is a proposition. But we're always interested to, particularly people who are already trading. We're always interested to talk to people who are interested in getting involved with Raspberry Pi. What powers Raspberry Pi? It's powered by commerce, and it's powered by people's self-interest. It's powered by people's desire to build businesses in order to have better lives for themselves and their families, and that's a good thing. We are big believers in capitalism, big believers in markets, and big believers in the power of entrepreneurial endeavor. All those guys, the three guys I mentioned, John, Paul, Jamie, they're all they're business people, and that's one of the things that makes them exciting people to hang out with.
So where do you see yourself 20 years in the future? What do you think would be the legacy?
I will tell you what my hoped for legacy with Raspberry Pi is. If one of the good things with Raspberry Pi is I've got to meet most of the people, a little bit like Bill Gates, actually, the people who worked on the BBC Micro are very young when they did it. And so they're still in the middle of their careers. This was a long time, this 40 years ago. But on the other hand, human beings live for a long time. And these are people who did this stuff when they were 20. And so they're still in the middle of their careers, really. They're people who've probably got another 10 or 20 years of working life ahead of them. I look back very fondly on my BBC Micro, and I look very gratefully on the people whose work gave me that experience. So what I hope the legacy of Raspberry Pi is, we sold 40 million Raspberry Pis so far. If one person looks back on the Raspberry Pi the way I look back on the BBC Micro, that will be a good legacy. And I will sit on the beach with my beer, and I will think good thoughts about that person in 20 years' time. Clearly, I very much hope in 20 years' time I'm still working on Raspberry Pi. Think of another role model. Thomas Edison said, that when he was old, that he pitied people who didn't have labs to go to. I pity people who don't have an environment like this to come to every day. I can't imagine back to the point about Bill Gates giving up control of Microsoft. I can't imagine myself ever wanting to not be here, because it's an amazing place that does amazing things, that's full of amazing people who I really like. And so I hope I hope my legacy in 20 years' time is I'm still at Raspberry Pi, and I hope that for somebody else it's been a gateway to an interesting life.
Awesome. This has been a really, really good conversation. A lot of information we got from you, Eben, and a lot of things to research for our listeners and viewers as well as me. I will check out the websites you mentioned as well. They sound very interesting. Any last message you want to convey to our audience?
Only the usual one, which is come to raspberrypi.org, see what we do. Thank you.
Absolutely. That's amazing. Simple and direct. Thank you very much, Eben. Amit, is there anything else you wanna mention?
Just want to thank you so much, Eben, for taking your time and coming on our show and giving such valuable insight. I'm pretty sure our viewers and listeners will take away something. And people in Africa and America, I just hope that they get access to a Pi and they can get onto the computing bandwagon and just improve their lives.